Hello everyone, let's start with 16th question. In this question we have two choices. Let's start with the first one. Define the term wavefront using Huygens wave theory. Verify the law of reflection. Okay. Wavefront. The wavefront is defined as surface of constant phase. The wavefront is generally a locus of point which oscillate in phase. Now come to the second part, which is using Huygens wave theory verify the law of reflection. Now consider a plane wave AB incident at an angle I on a refracting surface Mn. Here is the diagram of this equation for solving this. Let t equals to time taken by wave front to advance from B to C. That is BC equals to Vt. Let C represent the tangent plane drawn from the point C to the sphere of radius Vt having a as its center. Then A equals to BC equals to Vt. It follows that in triangle EAC and in triangle BAC, angle I equals to angle R has angle of incidence equals to angle of reflection. Hence, we have to prove this angle of incidence equals to angle of reflection. Now come to the second part. Define the term refractive index of a medium, and we have to verify Snell's law of reflection when a plane wavefront is propagating from a denser to a rare medium. Okay, the refractive index of a medium 2 with respect to medium 1 equals to the ratio of the sins of angle of incidence in medium 1 to the sine of angle of refraction in medium 2. Refractive index of medium 2 with respect to medium 1 and 2 1 2 is for second medium, 1 for first medium equals to sin I by sin r. And refractive index for medium 2 with respect to medium 1 we can also write as velocity of light in medium 1 divided by velocity of light in medium 2.